Hello everyone, we are Team Varuna AI from the Department of AI ML, MIT Academy of Engineering. So we are presenting a solution for the Samved Hackathon 2026. So our problem statement PS003 focuses on smart water pressure management for equitable water supply in Solapur Municipal Corporation. So this project aims to design a data-driven, smart system that ensures fair and reliable water distribution across all zones in Solapur. So let us now understand the problem context. So unequal water distribution is a critical challenge in the rapidly growing cities. So Solar Municipal Corporation it supplies drinking water to more than 10 lakh citizens across multiple zones. So despite having the infrastructure development, the city still faces major challenges. So many areas especially the elevated and the tailend regions experience low pressure and which leads to the dissatisfaction among the citizens. At the same time, the aging pipelines, leakages and manual valve operations, they cause significant water loss. So to summarize, the major challenges in the current water distribution system are the first is the low water pressure, that is higher elevation and the tail end zones receive insufficient water. Second is the pipeline leakages, that is, old and damaged pipelines result in continuous water loss and wastage. Third is the manual valve operations, that is, dependence on the manual control introduces human errors and delays in supply regulation. And fourth, that is lack of real time monitoring. Authorities they do not have live data on pressure flow, so which limits their proactive decision making. So to address this all challenges, we propose an IoT-enabled smart water pressure monitoring and management system.
This is our proposed system architecture for an AI powered smart water pressure management system. Starting from the left, the IoT layer, which includes pressure sensors, flow sensors, and ESP32 microcontroller and valve actuators. These components continuously collect real time water data from the distribution network. Next is the communication layer, where data is transmitted using protocols like MQTT and or REST over Wi-Fi or LoRa to ensure reliable connectivity. In the center, we have the cloud backend, which consists of an API server, database, and an AI analytics engine. The AI model analyzes pressure patterns, detects anomalies, and predicts demand for intelligent decision making. Finally, the application layer, which includes a web dashboard, mobile app, map view, and alert panels for real time monitoring and control. This system also provides control feedback by sending valve adjustment commands back to the IoT layer, creating a complete smart loop. This architecture ensures scalable, efficient, and equitable urban water distribution.
This Tinkercad circuit shows a real smart water supply system where potentiometers act as a tank level and the pressure sensors. The Arduino UNO controls the system. The DC motor represents the pump. Servo motors act as automated valves and the LED with the buzzer gives leakage alerts. This serial monitor displays real-time readings and system actions simulating IoT monitoring. Now, I will demonstrate the working of the system. When I reduce the tank level using this knob, the pump motor turns on automatically to refill the tank. When I increase the pressure, the pump turns off automatically. Next, when I increase or change any pressure zones of wall zone 1 and zone 2, then the walls automatically adjust, which represents the smart wall adjusting system. Now, for the tail end zones, when the zone pressure is low, the system opens valve more to give priority supply. Finally, when I reduce the pressure of the any zone, the leakage is detected and the buzzer and the LED get triggers. All these actions are shown on the serial monitor using the real-time simulating IoT-based monitoring. This model demonstrates how simple IoT automation can improve efficiency and fairness in the city water supply system.
Is a demo prototype for an IoT-based solution. So this is the main dashboard of our system, Aqua Control. At the top, we can see the real-time alerts and the notification. The center map shows a live pressure heat map of all the distribution zones in Solapur, which uses the color coding, where red indicates the higher pressure, blue indicates low pressure, and green remains neutral. So below that, there is a network overview where it notes the average pressure across the city, number of active leaks, critical alerts. So recent events they're also logged here, which includes the pump maintenance, manual overrides, or pressure spikes. So the screen 2 that is about the fault and the leak detection, especially for the pipe burst alert it is displaying. So this system has detected a pipe burst in sector 4, so showing a 65% pressure drop within 2 hours. So it automatically calculates the water loss per hour, flow velocity changes, and pressure profile drain. The system also provides an insight which recommends an immediate action such as closing a specific valve to prevent further water depletion. Then screen 4, it represents the hardware control, that is pump and the valves management. So for example, the main left pump status or the power consumption in kilowatts. So if required, operators they can start or stop pumps remotely. This screen is basically about the analytics and the reports. So it focuses on analytics and decision support. Here we can analyze the non-revenue water performance or the daily water consumption trends by the citizens. So uh, the system also provides forecasting using predictive analysis. So our IoT-based smart water management system, it transforms the solar's traditional water distribution into an automated infrastructure. Thank you.